Bismillahirrahmanirrahim. Welcome back to my channel. Today I'm back with another video, and it's not going to be a video which is going to be based on software defined radio. It's actually going to be a video about a very basic concept in applied electromagnetics using inductors. And nowadays this phenomenon is known as wireless charging. This has a name of wireless power transfer, wireless energy harvesting, and you name it. But the concept is at least, I would say, 100 years old. Since the invention of transformer, we've been seeing this concept where you have a primary coil and you have a secondary coil. They are not physically connected to each other, but somehow from that primary, using induction phenomena, secondary will induce some type of a voltage, and that is through electric or magnetic fields. So that's the device that I have here. This is a very crude design of a device. This is actually a wireless charger pad. You can think of it like a wireless charging pad. I have connected this to a power supply. So I just want to show you inside of the circuit. There's nothing fancy to it. This is just a copper wire with a couple of hundred turns. And this is connected to a circuit which is inside of this. As you can see, there is a chopper or there is a transformer. That transformer is actually converting that 220 volts to some volts AC, and this coil is the one that is, so that voltage is being induced into this coil using these wire which is connected to my circuit. This is just to show a very basic concept in electromagnetics, and I'll explain this in a little bit. Now, this is acting as a charging pad, and I have three different accessories. So this accessory also has a coil. Inside of it, I have three diodes and LED. That's just to show. So if I bring this close, the light is, it's not physically connected, but if I bring this close to it, the light, you can see the LED light which is shining. So if I take this away, this strength of an LED light is going down, and now no more. This is just to show. So this is, think of it like this. The concept is so old. Think of it like a primary and a secondary coil. This primary coil is being energized by the power supply. This is secondary coil, which is not actually connected to anything, but when I bring it close, you can see the light lighting up. And if I take this away, and there's no light. So the idea is quite old. It's more than 100 years old, but nowadays people are giving it a new name, and it's coming up as a new technology component. Like people are calling it wireless charging, people are calling it wireless power transfer, but this is at least 100 years old problem that we know how to tackle. Here's another accessory that I made. So this is just nothing but a coil that is connected to this circuit, as you can clearly see. This is just a regulator that is regulating, I think it's regulating around 5 volts. This is nothing but a bridge rectifier. You can just simply make this, and these are caps. Now, when I bring this, check this out. What happened to it? So this pad is not physically connected. When I bring this coil close to it, you can see the brightness of LED light. Here we go. Now, if I take this away, the signal is strength or magnetic field is going down. That's why you're seeing the dimness in light. But when I put this on top of this, you can see the brightness of my LED light. And if I take this away from it, there is no light. So idea is exactly the same thing. Now people are calling it a different name. The idea is very old idea, at least 100 years old, I believe. Now this is one of, now the third accessory is actually a charger. Just to show you, so this is your wireless charging pad. So my phone is not wirelessly charged enabled, but the idea is exactly same. The phones which are wirelessly charged enabled, they have a coil like this on the back of the phone. Now this is another copper piece of wire. This is just a regulator. Now this is a regulator. Now as you can see from the diode structure, this is nothing but a bridge rectifier. So when I put this charger here, you can see that charging light is on. Now I'm going to connect my phone. Wait for it. I'm going to connect my phone, and then I can start seeing that it's charging. Just give me a minute. And let me show you this. So now let's look at it. So this, I just put a wireless USB-C. So now let's look at it. When I connect this, okay, let me. So right now there's no charging. Now if I bring this close to it, now look what happened. I can see it charging. That this phone start charging. Because my phone is not wirelessly charge enabled. That's why. Now, I simply used a Vero board to make this, but this can be amplified if I just put it like this. Alright, you can see this is start charging. I'll bring it close. I can see this phone is charging. So, the reason I'm demonstrating this is just to show you that it is exactly a problem which we know how to solve. Now we are giving it a different name. We're calling it wireless charging or wireless power transfer. What is it that you're doing? Well, you're wirelessly transferring power from this coil to energize your devices. It's not physically connected, as you can clearly see. Only this pad is connected to it, and you, with using a couple of diodes and couple of capacitor and resistors and a piece of copper wire, you can come. The more the number turns are going to be, the stronger the magnetic field going to be. So that's the idea. That's the basic idea. We're just giving it a different name. The problem is almost 100 years old. If you remember in biot-savart law, what is it that you're trying to do? You're trying to find out the question that we normally ask when we are solving for Coulomb's law or biot-savart law. In the presence of a single charge, in this case it's distributed along this piece of wire, how much force is being felt on that particular point? This is the question we're asking in Coulomb's law. This is the question that we ask in biot-savart law. And these laws are almost 100 years old, or at least 100 years old. Exactly the same thing we're doing. In the presence of charges along, or charges or magnetic field on this coil, which is connected to a power source, how much force is being felt here? And the closer it is, the more force is, the more intensity of that light is. The further away it gets dimmer and dimmer and dimmer. So these problems are almost 100 years old, more than 100 years old, and we're still finding the application of these problems with different names. The concept is very old, but we're finding their application with different names. Where sometimes we're calling it wireless charging, sometimes we're calling it wireless power transfer, but idea is exactly the same. So I hope you understood what I was trying to demonstrate using this demonstration. If you have any questions, leave it in the comment section, and don't forget to like and subscribe to my channel.